8y equals 28.
Alright.
So Jeff, it'd be 13x plus 8y equals 28.
No. Again, what's the only time you actually add two equations together?
Oh, if they cancel.
When something cancels.
Oh.
So I know what you mean. When they will cancel, when they're the same and opposite signs. So once I multiply this by -3, if I multiply that by -3, I get -9x minus 6y. And again, you can put it right next to each of them to make sure that you don't leave anybody out. You multiply by -3 everything. Now these will cancel.
They cancel out.
That is the only time you add them together.
X equals -2.
Yeah, exactly. Now keep going. It was 2. Garrett.
2.
Yeah.
Oh, that's right.
Alright, so I'll let you guys finish that one.
And then you can just take the 2 and plug it into the X in one of those.
Exactly.
Plug and
Once you get
chug.
one letter, you plug it in to get the other letter.
Plug and chug, right? Plug and chug.
Plug and chug. Alright, guys. Here's what I'm going to do with section 4.2. We're going to talk about it. I'm going to show you an example, and then I'm going to make it extra credit. So we are going to talk about it. I want to show you how it works.
2.
Does everybody understand the
And it's
homework
just x
is extra credit? If you don't want to do it, you don't have to.
Okay.
Section 4.2. So I'm gonna mark that on the updated homework sheet when I give it out, that section is extra credit. Okay?
So we don't have to do it.
You don't have to do it, no.
So we don't have to take notes on 4.2 if we don't want to. So we're skipping right to 4.3 then?
Well, I'm gonna show you 4.2.
Okay.
So let's do an example from 4.2. Let's actually, well, let's do what's a little more interesting. There we go, number 5.
Oh my Jesus Christ.
Careful now.
Looking at the freaking problem set. Ooh. Freakiness. Bless you.
Thank
Now, what is horrific about this problem?
It's 3.
There's 3 unknowns. Why was this one actually, now looking at this, why is this one pretty damn easy?
You don't have 2, you have to get rid of 2.
I just have to kill one letter and I got one letter left once I kill it, right?
Right.
If here, if I kill a letter, don't I still have 2 letters left?
Right.
So just kill another one.
But then I just do this. Now to do this, how many equations do I need that have the same 2 letters in them?
2.
2. Let me say it again. If I have 2 letters that I don't know, how many equations with those 2 letters do I need? 2.
2.
How we doing?
You got it.
Which letter is the easiest to kill in there right off the bat?
Y.
You guys see that?
Yeah.
Using what?
Elimination.
Using which ones?
2 and 3.
2 and 3.
Oh, sorry about that.
So if you do, now,
Well, why wouldn't Z be easy too?
Because
a Z would be easy too. Yeah, I just want to see what people saw first. I saw the Y first.
Okay.
The Z's would be easy also. Yeah. If you add 2 and 3, so look what you would tell yourself so you make sure where the hell something's coming from. What do you get when you add those together?
Yeah, 5x.
X.
5x
Okay, minus Z
Plus X.
plus Z
equals 11.
11.
Yeah.
Right?
Okay.
Now that's a better equation. Why? Why is that better than any of these?
Because mine is
You already eliminated the Y.
Because there's less stuff you don't know.
Yeah.
Right? Isn't that a better place to be?
Yeah.
I still don't know stuff, but there's less stuff that I don't know, right? Are you guys kind of with me?
Yeah.
Now, why is that kind of, now watch what I'm going to do. That's my 4th equation, isn't it?
Yeah.
So it's all about bookkeeping in this, right? The people that are really sloppy, and I count myself amongst those. That's why, for me, I definitely had to do this, bookkeeping. You got to keep track of what the hell comes from where and what is it.
Yeah.
That is my 4th equation.
Right.
And that equation is better than any of these. But what is it missing? Doesn't it need some help? Doesn't it need another equation that has
Yes.
X and Z? Isn't that why I said this twice? How many letters do I not know in that equation, number 4? 2. Don't I need another equation that's got those same 2 letters so I can attack it like this?
Yes.
How do I make another equation?
1 and 3.
I love it. Now you start to see it. Now it's even better though to use, a little bit better to use 1 and 2 because at least they're opposite sides. Do you see that? And that, if 1 and 3 would work, but that's what I always look for is what has opposite signs already. So really, if I use 1, let me write 1 here. And what I want to do with 2.
Multiply by 2.
So 2 I want to multiply by 2. You guys see that? So really, it's, once you get this pattern down, it's the same thing every time. Pick your letter. Kill it once, kill it twice, and then attack it just like you would back here. Because now you have 2 equations with 2 letters.
Okay.
Again, why do you think they gave me 3 equations in the beginning?
So you can find 2 equations out of it.
Exactly, because I got 3 things I don't know. That's the only way I can actually do this, right? If I got 3 things I don't know, they better tell me 3 pieces of information.
Oh, okay.
So what do you get when you multiply this by 2? You get
4x minus 2y
2y
plus
plus
4z
4z
equals 12.
I love it. And again, if you needed to, you could put 2 next to everything so you don't forget anybody, right? And what do you get when you add those together? So 1
You get-
plus twice 2
okay,
will be equation 5.
3x. I mean 5x
These are gone.
plus 5z equals 15.
And that's equation number 5.
What? What is it? Is it 5x?
Yep. So 1x plus
Yeah.
4x. Cool. What's really nice about that equation, you can see right off the bat.
The 5 goes into everything. So
Exactly. So whenever you see that in an equation, do that immediately because then you have smaller numbers. So what's 5 actually? It's divide by 5. X plus z equals 3.
What is the last one? What is it?
Just divide it by 5. Because 5 goes into each. Right?
Why you to get
To make the number smaller.
Okay.
And what's the most beautiful coefficient to have? 1. Right? Don't I have a coefficient of 1 of both those bad boys? Right? So now I've got equation 4 that I reasoned out from what they told me. So I got equation 4. 5x plus z equals 11. And then I got equation 5. X plus z equals 3. Between those two, can you kill something?
Yep. Whatever you want.
Exactly, right? Stay with me now. I know a few of you guys turned off right when I said extra credit. I know that, but those of you who didn't immediately turn off, stay with me. So like you said, Manuel, you multiply one of them by -1, right? I'm just going to multiply, it doesn't really matter. -5x minus z equals -11. So you get -4x.
4x
And then
equals
cancels equals -7, -8.
Divide by -4 and got x equals 2.
and then you plug
And
it.
Then you plug that, now it's like dominoes. Plug that into here to get z, right? And what do you get for z then? So if I plug in the 5, 2 plus z equals 3, z is 1.
Oh.
Now how the hell do I get y? What's the only equations up there that have y in it?
3.
The original ones.
Uh-huh.
So don't I have x and z?
Yes.
So couldn't I just put, like in number 1, x, which is 2, plus twice y plus z,
Equals 1.
which is 1, equals 3. Dominoes. Get a letter, plug it back in there. Get another letter, plug both of those back in the beginning. It falls back.
Okay, it's gonna be.
Work forward, fall back.
That's gonna be 3.
It's spring forward, Paul.
3 plus 2y.
2y equals 3. Okay, divided by, minus 3.
2y equals 0, so y equals
0.
0.
0. Can somebody tell me what the answer is?
So X,
Okay,
Y, Z.
No, no solution.
Zero.
Order pairs.
0, 1,
We got a solution. 2, comma, 0, comma, 1.
1, yeah.
Now, with these, and again, this is extra credit. I hope you guys kind of got the idea here. I want to show you one example, and you can come see me if you need some more help on that, but I want you to see something really interesting. Here, I can do that on a board, can't I? Can I draw both of those if I wanted to? I can graph them both. Because these only have 2 letters, they're only 2-dimensional.
Yeah.
But how do I find, how do I find this point? I can go over so much and up so much, right?
Yeah.
You guys with me? So I just need an x and a y.
Yeah.
How do I find that point?
Is it?
Right there. Then I have to go over, up, and out. That's why I need 3 letters for 3 dimensions.
Yeah.
So So this is still physically valid. This is now I could talk about 3 dimensions. And we live in a 3-dimensional world, so this is actually closer to real life. You guys kind of with me here? Or, for example, this could be, I expect this many people, adults, kids, and seniors to show up, and this is how much it costs for each person, and I can put together a whole thing based on a given physical situation with 3 things that I don't know. So each thing can get its own letter. X for adults, Y for kids, Z for seniors, right? What do I need to be able to solve it? 3 different pieces of information. Right? How many people are going to come? How much money do I want to make? And something else. How much weight can my stage hold? I'm going to be on the stage. Right? They're like all restraints, constraints to a situation possibly. Okay, so again, that is extra credit. And it's always the same. Pick a letter to kill. Kill it once, kill it again, and then you're back in the earlier section. Now you've just got 2 letters you don't know. You use straight up elimination then, right? It's always the same pattern.
Another one.
No. No more.
Oh,
No. I'm trying to catch up a little bit too. Alright, so just so you know, I'm not skipping around a bunch. Already on the outline, we only had 3 sections out of 4 to do. It was 4.1, 4.2, and 4.5. So we're going to get to 4.5 now, which you've been anxiously awaiting, is the system of equation word problems. I got no groans on that, so I guess you guys are either all still turned off.
Oh, no, yeah, we've been waiting for that, yeah.
Yeah, I'm just trying to figure it out. I'm trying to copy it, but I'm going to shout it too.
Word problem.
So what should we title our notes for as it, Jeff?
What's that?
What should we title our notes? Word problem systems?
Section 4.5.
System of equations.
Applications of systems of equations, if you want to be totally technical.
What? Exactly.
Applications for systems of equations.
I was joking, of course. I understood what you said.
Cool. So let me give you a type of problem I would definitely give you on a test, and you see very often in the homework here. Let's say you go somewhere and you buy 4 hot dogs, so you don't have to eat for the rest of the week, and 3 orders of fries, and that costs. Let's see what will mix it. I don't know. Wait. Wait. Don't say anything. You gotta make this make sense. $5.50. 50. All right. So long this month. You buy 4 hot dogs and 3 orders of fries, and that costs $5.50. Is that enough information to solve how much a hot dog costs and how much a French fries costs?
No.
Yes.
No.
Is it?
No.
How many things don't you know?
3.
2
Fries.
hot dogs and French fries, and I only gave you 1 piece of information here, didn't I?
Yeah.
From this piece of information, could you write an equation?
Yeah. No.
Yeah.
Okay?
The cost of 4.
And here's the cool thing: 4 hot dogs and 3 fries. So 4H. You with me?
Yeah.
That's 3F.
Plus 3F
Equals 550.
equals 550.
Yeah.
Cool. How you guys doing? Do you guys see how that is actually easier than the word problems we did in section 2.3, I think it was? That's actually easier. It sets itself up. 4 of these plus 3 of these equals this. Bam. And I'm going to normally, it's a good idea to use letters that go right along with the idea. Bless you.
Bless you.
So I still need to give you 1 more piece of information. Bless you. Right? Because how many answers are there for this equation?
1.
No. Come on.
1.
Fries.
You're making me cry.
Right.
3 is closer.
4.
Infinitely many answers.
Okay.
Now, of course, you would throw out, obviously, the negatives unless they were giving it away and paying you to take it. Right? But still, really, there's an infinite number of answers.
Why? I don't understand that. Yeah.
Because what could h be?
Oh, cause you just plug it